Hi guys, Sajjad Hussain again with a new video. In this video, I'm going to design a matte foundation in SAFE 2000. So let me import the file. In my last video, I used this same file to design the isolated footing. Now I shall be using the same file, same input data file to design the matte foundation for this building. So here is the plan. Let us define the slab properties. Let it be matte slab or foundation slab. So we will call it foundation slab, and its thickness was 39 inch. In my last video I selected 39 inch because of the shear, so the same thickness I'm using now. Let me define the columns also. Here there were two types of columns, internal and external. The internal columns were 30 inch by 30 inch, and the external columns were 28 inch by 28 inch. Okay, so let us define the slab first. So this is the slab. Let us select this slab. Okay, and let us define the offset. So here edit areas, expand or shrink. So let us offset it by, say for example, 36 inch. Right. Now we can define columns. Here column below none, column above let's say internal, height below is 0, height above 6 feet. So let us assign the columns here. These are the internal columns. Similarly, we can define external columns. So the external columns are drawn here. Okay, so let us save this file. Let us save this as raft foundation. Let's have a 3D look. So we can see that the support conditions are also transferred. So let us select all these and let us remove these support assignment, point support restraint. Let us remove this one. Okay, now we have the loads. Let us define the load combinations. Default load combination. We are not interested in service initial and service long term. We are interested in ultimate strength load combination and normal service load combination. Okay, as usual, as before. Now we have to draw the design strip. Now in A direction, let's design the column strip. The column strip is 12 by 12 by 12 by 12. That means both sides 12 feet wide. This is the column strip. So let us define the column strip here. Another column strip. One more column strip. Here also. So these are the column strip in A. In layer B, let us define the column strips. Another column strip. Okay, we can assign for the edges also. Let the column strip on the left hand side or for the time being leave it as it is. We can also define the middle strip. So our middle strip is this one. Similarly, we can design all the middle strips like here. So all these middle strips we can define here, also here. This is in layer B. Let's see the design preferences. Minimum cover will be 3 inches, 3 inches. Let it be number 8 bars. Code is 31808. Okay. And let us see the design combination. Okay. Let us run analysis and design. So here are the deflection. Let us display the reaction for load combination N2. Sorry, we missed one thing. Select slab properties and assign soil properties by default. So here is the soil properties assigned. Now let us save the file, run analysis and design. Now let us see the soil pressure. For load combination N2, let us see the soil pressure. So the soil pressure is maximum at the edges, in between is very small. So because of this matte foundation, we can see that this soil pressure is within the limits. If we see the deformed shape for same load combination, so the maximum deflection is only 0.3 inch over here, 0.2, 0.2, 0.3 inch at the most. So the deflection is also within the limits. Now let us see the reinforcement. Show the slab design. Both the strips show the bar, impose minimum reinforcing. Let us select number 8 bars in both the directions. Let us apply. So here is the bar distribution. We can see all the bars are here. So you can see how many bars are there. Now we can run detailing. Okay. So here is the plan. Let us see the drawings. Here is the slab framing plan. These are the bottom bars. The bottom bars are also here. Section. The bars and the sections are here, already defined. It's another direction. So this is the way we can design a raft foundation in SAFE 2000. One more thing, let us check the punching shear. That was very important. Display punching shear. It's a little bit higher here. We can increase the slab thickness. Define. Okay, let's run one more time. Define slab properties. 42 of an inch. Okay, let us save, run. So let's see the punching shear design. Now all are less than 1, so that means this is okay, perfectly fine. So this is the way we can design the matte foundation. We can transfer the data from SAP 2000 to SAFE, and then in SAFE we can design the matte foundation. I use the same example which I have been using before. Maybe you can see my previous videos. In that videos I used one model only, that was the 12-story building, and I took that example from PCA notes ACI 31808, and the example number was 11.2. You can check my previous YouTube channels, YouTube videos. And the same data file I have used here also In my last video I designed isolated footing, and now I'm designing the mat foundation for the same problem. So now you can see how even the isolated footings are designed, or how a mat foundation is designed, how easy it is to design a mat foundation or a isolated footing in CSI SAFE 2016. So hopefully you will like this video. It was a very short video but very informative. Please do not forget to subscribe my channel. Thank you very much for your appreciation. Thanks a lot.